Determine for the function f of x equals x squared minus 5 for x is less than 1, negative 4 for x equals 1, and 3x squared minus 5x minus 2 for x is greater than 1, at the x coordinate x equals 1, whether it is parts a through e. Each of the parts involves the continuity of the function. The first thing to do is write down the definition of what it means to be continuous. And that will be limit as x approaches a from both sides of f of x equals f of a. Specific to this problem, we're looking at the x-coordinate of 1. So we can now write down for an x-coordinate of 1, limit as x approaches 1 from both sides of f of x equals f of 1. Now we don't know whether this is true yet or not, so let's put a question mark above it. The first thing to do is determine the two-sided limit as x approaches 1 from both sides of f of x. Since f of x is a split expression function, and the split is occurring right at the x-coordinate of 1, we will have to work out the two one-sided limits separately. So we can write down the left-sided limit, indicated by the negative superscript on the 1, and the right-sided limit, indicated by the positive superscript on the 1 of f of x. Let's start with the left-sided limit. The left side of 1 on the number line means less than 1. Up here, the split expression function, that means we will use this for the expression. So we can replace f of x with x squared minus 5. The next thing to do is try plugging a 1 in for each of the x's. That will give us 1 squared minus 5. 1 squared is 1. Minus 5 will give us a negative 4. Now we can work out the right-sided limit. The right side of 1 on the number line means greater than 1. Up here at the split expression function, that means we will use that for the expression. So we can replace f of x with 3x squared minus 5x minus 2. The next thing to do is try plugging a 1 in for each of the x's. That will give us 3 times 1 squared minus 5 times 1 minus 2. 1 squared is a 1, minus 5 times a 1 is a minus 5, and then minus 2. 3 times 1 is a 3, minus 5 minus 2 gives minus 7, and 3 minus 7 is negative 4. To determine the two-sided limit, we will compare the results of the one-sided limits. Here they are, and they match. They're both negative 4. Therefore, the two-sided limit is that same value. It's a negative 4. The next thing to determine is f right at 1. F of 1 is determined with the split expression function where x is able to equal 1, and that would be right here. And according to that, the f of x is negative 4 when x is a 1, so f of 1 will be negative 4. So what we have here is the limit as x approaches 1 from both sides of f of x does equal f of 1. This can also be written as limit as x approaches 1 from the left side of f of x equals the limit as x approaches 1 from the right side of f of x equals f of 1. We have situation A happening, which is continuous.